Coastal erosion is a cumulative impact, both natural and artificial. Natural losses are subsidence, decay of abandoned deltas, waves, and storms, and artificial losses are flood control practices, impoundments, and oil dredging, and subsequent erosion of artificial channels. All beaches are affected by storms and other natural events that cause erosion. However, the extent and severity of the problem differs in different parts of the country, and so there is no one-size-fits-all solution. In the United States, coastal erosion is responsible for roughly $500 million per year in coastal property loss, including damage to structures and loss of land. To mitigate coastal erosion, the federal government spends an average of $150 million every year on beach nourishment and other shoreline erosion control measures. In addition to beach erosion, more than 80,000 acres of coastal wetlands are lost annually, the equivalent to 7 football fields disappearing every hour of the day. Some impacts of land erosion are increased saltwater intrusion, loss of capacity to buffer storm surges, and large additions of nutrients. A good example of an area affected by coastal erosion is Louisiana. Coastal Louisiana wetlands make up the 7th largest delta on Earth. According to USGS, these wetlands are in peril because Louisiana currently undergoes about 90% of the total coastal wetland loss in the continental United States. Currently, the levees of the Mississippi River used to control the river and protect communities actually create problems for the ecosystem because the delta's wetlands have been built and sustained by sediment deposited by the river. These levees cut a connection between the sediment-filled river and its delta, which stops the wetlands from regenerating land. So why are these marshes so important to our coastline? Marshes act like a sponge. They absorb a lot of the water that intrudes the coastline when a storm comes crashing in, as well as helping control the aggressive surges of water from sea level rises. They are also habitats for a variety of plants and animals. These marshes can even affect climate change directly by pulling harmful carbon out of the atmosphere and converting it into a useful nutrient in the soil. For the past 25 years, the U.S. Geological Survey has been studying land loss and coastal erosion in Louisiana, and their data has indicated that over 34 square miles of land has been lost per year in the last 44 to 50 years. There are several solutions to this problem. One of them would be to install new water control structures to control salinity and maximize the flow of the fresh water. Another way would be to create marsh terraces, which are low duck-wing-shaped ridges made from existing bottom sediments. Using these techniques, they can be used to convert newly formed shallow waters back into marshes. Marsh creation uses sediment from nearby water bottoms to build land in shallow open water areas, typically where land has been lost. These projects can build land quickly, but marsh creation alone is not a long-term sustainable solution for land loss. What can be done is it can be used in combination with sediment diversions to help trap sediment. In turn, sediment diversions can benefit marsh creation projects by providing a long-term source of sediment that can help lengthen their lifespans. Another example of a good solution would be to use hydraulic restoration, which restores freshwater flows through man-made channels, gates, or similar structures to reduce or prevent saltwater intrusion, which can be harmful to wetland marshes. Other examples of ways that would be good to use for solving this problem would be planting vegetation and erosion control mats made out of natural fibers that slow erosion because sand and other sediments get held back and trapped in the mat's fibers. Coconut fiber logs are used on the beaches to help with sand erosion and can be put in sand dunes to help establish roots.